Okay, I will share all the blocks, all the sections of the syllabus. Okay, so today we will discuss the knapsack problem at first. The knapsack problem, which we have discussed in the greedy approach. Okay, now we will try to make a program for this. At first, I want to tell you about what is the problem. In the knapsack problem, we have to select the best solution, okay, in which we have a set of n items and each item has a value and a weight, corresponding weight. Okay, in the algorithm, in the program, you will see that each item I has a value vi. The value will be denoted as vi and a weight, that is wi, and the condition will be the value of I that will be greater than 0 and less than n, and we are given a maximum weight w, that is the maximum capacity w, and the problem is to find out how much of each item we should take such that the total weight does not exceed w. The w is the knapsack, that is the maximum capacity of the knapsack. So the goal is to find.
Sorry, sir.
Yeah.
Uh, Please zoom the word page
Okay,
so
okay,
we can't see it.
okay. Now it is visible.
Yes, thank you.
Okay. 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 So the goal is to find of each item we should take such that the total weight that does not exceed w. W is the maximum capacity of the knapsack. That is the constraint, and the total value is maximized. It means we can get the maximum value. So we want to find f such that the sum of vi and fi, the value and the fraction, that is vi is the value and fi is the fraction, overall I is maximized so that the item's value will be maximized. This will be the problem to make a program. Okay, this is a complete problem description of your knapsack problem. In the knapsack problem, we have n items and each item has a value vi and a corresponding weight wi, where the value of I and n that will be greater than 0 and the I will be greater than equal to 0, and we have a knapsack which capacity is w, and we have to find out the goal of the problem, and the problem is to find how much of each item. How much means the fraction, that is denoted as f of I. The fraction of each item we should take such that the condition will be that total weight does not exceed w. The total weight that will be equal to your w, that cannot be greater than w. That will be the problem. Now what will be the solution? This is the solution of your knapsack. The problem solution is the function fractional knapsack is defined. Okay, it is clearly defined. It takes 3 arguments. Here you can see in the program also. Here we will take 3 arguments, 2 list values and weight. One is for value and its weight, and another is for a number of capacity. So we have taken 3 arguments in the program. And it will return what it will return. It will return the maximum value and fractions. That is the goal. It will return your maximum value and fraction, where max value is the maximum value of item. It is the maximum value of item. I will also share this and this text in your group. Okay. So it will return max value, that is the maximum value of items, and the fraction. Okay. And which the total weight not more than the capacity. This is the condition. And fraction is, what is fraction? Fraction is a list where fraction fi, it is the fraction that should be taken of the item. From the item I am taking the fraction of these elements, these items, according to get the maximum value. Okay, where the condition should be, the value of I should be that be greater than 0 or equal to 0 and less than your total number of items. Okay, next, the function works by choosing an item from remaining items that has the maximum value to rate. Every time I will select an item with maximum value. If I have found the whole item and the value is less than the knapsack, then I will put it the whole item in the knapsack. Otherwise, I will take a fraction of that item and I will put that the maximum value to the knapsack. Okay, so the function works by choosing an item from the remaining item that has the maximum value to the weight ratio. Then if the knapsack can include the entire weight of item, as I have told that, if the knapsack can include the entire weight of the item, then the full amount of the item is added to the knapsack. Okay, if entire weight can be fit in the knapsack, then I will put the entire full amount of the item in the knapsack. Otherwise, if not, then only a fraction of item is added in the knapsack. Okay, if the knapsack can include the entire weight of the item, then the full amount of the item is added into the knapsack. Otherwise, only a fraction of a particular item is added, such that the knapsack becomes full. And the above three steps, these three steps are repeated until the knapsack becomes full. These three steps, 5, 6, and 7, these steps are repeated until the knapsack becomes full, until I have not achieved the maximum capacity. That is, the total weight reaches your maximum weight. That is the solution. Now we will make a program for it. This is the source code. This is the program. Okay, I have also written the commands also. Okay, I have passed three parameters here. Fractional knapsack, I have taken a fractional knapsack with value of each item, corresponding weight, and the maximum capacity, which I have already told here that it takes three arguments: two list value and weight, and another is capacity. So here are three arguments. One is value, another one is for weight, and another is it will describe the maximum capacity of the knapsack. Okay, it will return the maximum value. It will return the maximum value of items and their amounts. It is a command. Okay, and the first two, maximum value and fraction, maximum value and fraction is returned where maximum value is the maximum value of items with total weight not more than the capacity. This is not part A program. This is the command section. Okay, it will return the maximum value of item and their fraction amounts, and these two parameters, these two arguments, max value and fraction, it will return where maximum value is the maximum value of item with total weight not more than the capacity. And fraction, second one, fraction is a list where fraction f of I is the fraction that should be taken of item I. If it is not completely in the knapsack, then I will take a fraction of a particular item. Okay, that will be in the knapsack. So the fraction of a list where fi is fraction that should be taken of item I where I is greater than 0 and less than the total number of items. And value I, this I, value of I, it is the value of item I, and wi, weight I, is the weight of the item I. And for 0 to, this is a loop where n is the number of items. This loop will be executed 0 to n. It is a Python program, you can see that. And the capacity is this capacity is the maximum weight. Okay. Now, first one, this is the first line of the code. After that, after this second line, this index list range length value. So it will describe the index. It means for the n items. It is defining the length of your values. The range 0 to n minus 1. It means for n items. Second one, next in the next step, I will find out the ratio. And this contains the ratio of values to the height. The ratio equal to weight of I divided by W of I for V and W in zip value and weight. So I am calculating the ratio. On the basis of this ratio, I find out that which have the maximum profit. Okay. Then index is sorted according to the value to weight ratio. According to this ratio, as we have already discussed in the numerical program, that we sort this ratio in the decreasing order, because I have to take the maximum value in the knapsack in the first item as a first item. So index sort key lambda I ratio, I will sort this value which I got, the ratio, that is ratio of I, in the decreasing order. And the maximum value, initially the maximum value is 0. And the fractions, that will be 0 into the length of value. Okay. It means if it is I am taking complete, it will be 1, otherwise it will be the fractions. Okay. Then in the for loop, this will be if the weight of if the weight of I am checking the condition. If the weight of I that is less than equal to capacity. Every time I will check the capacity. The knapsack is capacity is full or not. If it is not full, the weight of I is less than equal to your capacity, then I will increment it by 1. Then the fraction of I equal to 1. Okay. And I will add the maximum value with the value of I. Maximum value equal to max value plus value of I. Initially the max value is 0. Then after that, what will be the value of I? That will be added, and that will be the final max value. Then that weight of I, that will be the capacity. Okay. Now what is the remaining capacity? The remaining capacity will be total capacity minus the weight, as we have put in that. That will be the next remaining capacity of the knapsack. As otherwise, if this condition is not, then fraction of I, in the here I have taken the whole item. Now else otherwise, fraction of I equal to capacity divided by weight of I, and the max value equal to value of I into capacity divided by I. Then this loop will be completed. It will calculate your capacity of knapsack also. What is the present capacity and what will be the capacity after containing a whole item or a fraction of item, and what is the remaining capacity of the knapsack. Then it will return the maximum value of fractions after that, and it will be your number of inputs, number of items, how many number of items you want, I will put the value of each items, and I will also put the weight of each items here. What will be the weight? What will be the value? Sorry, what will be the value and what will be the weight of each item? And capacity. I will also enter the maximum capacity of the knapsack. Okay, and this max value fraction, this is your here max value and fractions. It will return the maximum value in the maximum value of items with total weight not more than the capacity. This line will tell that. It will print the maximum value of items that can be carried, that will be your max value. So we will print the fraction in which the item should be taken. After that, when we run the program, okay, after running program, the user is prompted to enter the number of items. Here we are entering the number of items. You will give the number of inputs. Then the user is taken as to the value and weight. We will also enter what will be the value of each item and what will be the weight of each item. Then the function fractional knapsack is called to get maximum value and the list of fractions. That we will calling the fractional knapsack. Okay, the fractional knapsack function that is called. After that, after putting the number of items and weight and I, the fractional knapsack is called. The fractional knapsack is defined here. This is your fractional knapsack, and the whole program will be executed. Then the result can be displayed. So runtime cases, what suppose in the first case we have entered the items, 3 items. Okay, then it will ask the value of items. Suppose I have written the value of items 60,120. Then it will ask to enter the weight of items. These are the corresponding weight of these 3 items. Then this is the maximum weight. This is the knapsack capacity. Knapsack capacity is 50. Then the maximum value of items that can be carried as 240. How the 240s came? These 240s came according to by calculating the VI upon WI, that is calculated here. This is the ratio V upon WI, and I have then sort these items according to the decreasing order, which have the highest value. I will put that item in the knapsack. If the knapsack is completely fully filled, then I will not insert any item in the knapsack. I will not put any item in the knapsack. If there is a remaining space in the knapsack, then this fraction of I is inserted, put it in the knapsack. Then after, according to this, the knapsack value is calculated. In the second case, I have entered 5 items, corresponding values as well as the weight of, and then I have entered the maximum knapsack weight capacity. Then I have found the maximum value of item according to the program. So this is a program, this is a Python program for a knapsack problem with the help of your greedy approach. Okay, this is a knapsack problem with the help of a program. According to this, I will make a program of this, and I will share this Word file in your group, and you have to try this in your systems, in your laptops. After running and the given code, you can check that it is giving any output or not. So you have to do it yourself in the system. This is a program, this is not algorithm. Okay, this is a program of a knapsack problem. Next problem is, this is one typical one simple problem that is merge algorithm. Okay, we have already discussed divide and conquer approach. Okay, in the merge algorithm, how will you make a code, how will you write a program for merging, for sorting an algorithm? So for this, you can see These are steps and problems. So here you can see that a noticeable difference between the merging steps we describe are the, okay, this is not in this code here. Yeah, the merge function is here. This is our task is to merge two subarrays P and Q, Q1 and R, and sorted array P and R. This is the input. Okay, so in merge sort, in divide and conquer approach, what I did, we have divided the problem in just equal to halves. After that, we have divided the divided arrays further to half. We will divide the problem until it becomes minimal. Minimal means until I have not get a single element. I will divide the problem until then. After dividing, I will merge. I will conquer. I will solve independently all the problems. And after that, I will merge the solution. I will combine the solution. And then I will find out the overall solution of a program. So in the merge sort, I will take 3 pointers I, j, and k. I will create some arrays p to q and one for merging. I, it maintains your current index of first subarray L that will be started at 1, and J, it maintains the current index of M second subarrays that will be started at 1, and K maintains the current index after merging a PQ starting at P. So I will take these three until we reach the end of either L or M, because I am merging according to the comparison of this. So until we will reach the end of L of M, we will pick the larger among the elements from L and M and place them in the correct position. Where we will put it? Where will we place them? In this array. Okay. So in both subarrays L and M, I will compare the elements and I will pick the larger among the elements from L and M and place them in the correct position at the array, that is A, P, and Q. And when we run out of the elements of either L or M, we will pick up the remaining elements and put in the array. If there is no last element or no element, or is there any single element remaining in L or M, I will just pick up that remaining elements, I will directly put it in the array. That will be the logic. Then how will you make the program? This is a Python program. We will merge two subarrays. First subarray, it is array 1 to M in first middle part, and second subarray, that is M middle plus 1 to R. R is the last position. L, this is the first position and this is the last position. This is middle and this is middle plus 1th element. Okay. This is merge procedure array L, M, and R, where N1 is M minus L plus 1 and N2 is R minus. This is a merge procedure in which I have created two temporary array. These are subarrays. One is L, another is R, where and initially the value is 0. Okay, no is there. Then I will copy the data to these two arrays. Copy data to temp arrays in R. So I will write down a for loop there, the for I to range N1, and array of each element that will be inserted in array li, that is subarray, and one j loop. This is I loop. I loop is for maintaining the current index of this first subarray, and j is for maintains the current index of second subarray. Okay, so this is maintaining for your first subarray and this is for your second subarray. This is your first subarray, this is your second one. So I am inserting the elements from first subarray and second subarray. Here I am copying the data. Okay, then merging the temp arrays back into the array. Okay, now I'm merging. How I'm merging? This is the until we this is here until we reach the end of it. What we'll do? We will pick the larger among the elements from L and M and place there. So I will compare both the elements of different subarrays, both the subarrays, and I will put that element in the correct position. That will be done now. And here J, it is the initial index. I is the initial index of our first subarray. J0, it is the initial index of second subarray. And K, from first, it is the initial index of merge subarray. Merge subarray will be the final subarray. So this is the conditions. What will we do if I is less than n1 and j is less than n2? Okay. Now here I am comparing the elements. The first element of first subarray and first element of second subarray. If L of I is less than equal to R of j, it means if first element of Li that is less than or equal to second element of R of I, R of j. If first element of first array that is less than equal to the first element of second of array, then what will I do? Then I will put the first element of first array in the final array. So I have write down the Li in the array of k. K is our final. And I will increment the value of I. Now I have incremented the value I equal to I plus 1. Because the first element is inserted in. Now I will increment the value of I. Now the second element that will be compared with R of j. Now first array elements will be compared with the, the second element of the first array that will be compared with the first element of second array. Now that will be compared. Else otherwise the first element of if this condition is not fulfilled. If the first element is greater than R of j, first element of the second subarray, then the second subarray element that will be less than first element of the subarray. Then I will put the second array, the first element of the second array into the array k. This is the final, and I will increment the value of j into j equal to j plus 1. I will increment the value of j, and after that, after this, I will increment the value of k, because at k position I have inserted a value in its correct position. So next time I will insert the value, sorry, I will increment the value of k. Okay. This will be done for both subarrays. It will be repeated until I have not find out this condition. Then if then after that I will copy the remaining elements of phi if there are any. If there is any remaining elements, find out. After overall comparison, then I will insert this element in the array of k, and I will increment the value of I and k of 1. And if there are any remaining elements in the second subarray, then I will insert those elements in the final subarray. If there are any remaining elements in the first subarray, then I will insert those remaining elements in the subarray, sorry, in the merging array, that is the final array. If there are any remaining elements in the second subarray, then I will insert them in the final subarray. Okay, here the L is the left index, R is the right index, and this is our ARRA. This is for our final array. So this is the conditions. If L is less than R, merge sort. Okay, initially same as I have calculated it. Okay, the middle one, first plus r minus 1 by 2. Then the first, this function is called, which we have discussed earlier. Then second is called, and up in the last, then the merge procedure is called, in which we will find the overall final subarray. So at first I have sorted first half, then second half, and by comparing both subarrays, I have merged the solution. So in merge sort, I have divided the problem into just equal to halves, and after that, I have find out that uh, I have merged these two subarrays according to the correct position of these elements. Okay, this is done in this program. This is the merge sort program. Okay, and this is done here. Okay, this is next is our second one is our quick sort. Okay, another program for divide and conquer approach, which is also in your syllabus. Okay, all these programs are in your syllabus. So next is our quick sort. Okay, so one Python program also for your quick sort. Like our merge sort, quick sort is also an algorithm of divide and conquer approach. In this, I will take a pivot element. According to that pivot element, I will divide the array by putting that pivot element in its correct position. By checking that all the elements on the left side of the pivot that will be less than the pivot element, and the elements which are in the right side of the pivot that will be the greater than the value of our pivot element. So according to the pivot value, I have divided the problem. Not like merge sort. In merge sort, we have divided the problem just equal to halves. But in quick sort, I will divide on the position of our pivot value. The pivot value can be anything. The pivot element can be in any position. Okay, so the quick sort performance depends on the position of our pivot element. If every time I get a pivot element in the middle one, then quick sort will work as a best case. Then the performance of quick sort will be the best. If I am getting the pivot element in the last position or in the first position every time, then the performance of quick sort will be the worst case. Then that will be the worst case of the quick sort, because the maximum height of tree at that time that will be what, n, and every time it is taking n time. So the total complexity will be n into n, that will be your n square. And if it is in the middle one, so the height of the tree that will be our log n, and it is taking n time for each level, so that complexity will be n log n. Okay, so in the quick sort, it picks an element as a pivot and partition the given array around the picked pivot. According to that pivot element, I will partition the algorithm according to that pivot element. So there are many different versions of quick sort to pick the pivot elements. It depends on, first is always pick the first element as a pivot. If you pick always the first element as a pivot element, then, or you can also pick the last element as a pivot. Every time you can pick the last element, or you can also use a random generator also here. Pick a random element. Just use a random generator function in the program. and the random generator will generate a random value of pivot element. You can also take a random element, or you can also pick a medium element as a pivot. So every time there are four ways to sorting. Always pick the first element as a pivot. You can also take last element as a pivot, or either you can use a random generator as a pivot, or pick a medium element as a pivot. It depends on you, according to you. So in this program, I have taken the last element as a pivot element. In my program, I have taken as a last element as a pivot element. So according to that pivot element, I will partition the program. I will partition the array. So the key process of quicksort is, key process of quicksort, that is partition algorithm. Because according to that partition algorithm, the quicksort, the analysis, the performance of quicksort, it varies according to the selection of our pivot element. So the target of partition is given an array and an element of x of an array as a pivot, put x at its correct position. As I have told, just put a pivot element, just pick a pivot element x and put that pivot element in its correct position in a sorted array, and put all smaller elements smaller than the pivot, put all smaller elements before x. It means put all the smaller elements on the left side of the pivot element, and put all greater elements which are greater than the pivot, put all these greater elements on the right side of the pivot element. And all this should be done in the linear time, and this must be in the linear time. Otherwise, if you are not doing in the linear time, the complexity will be increased, but it will be done in the linear time. Okay, then there is a code for this. This is the code, Python code for quicksort implementation. Okay, so in this implementation, it utilizes pivot as a last element in the numbers list, and it has a pointer to keep track of the elements of smaller than the pivot. And at the very end of partition function, the pointer is swapped with the pivot element in the partition function, because partition function is very important in this. Okay, so this is the function to find the partition position. Here is the partition. This is very important. It is a given array. Low is for initial index, high is maximum value, it is minimum value, minimum location, and high maximum 0 or n-1. You can take also anything also. So I'm taking the last element, choosing the last rightmost element as a pivot. It means the pivot value will be array of high. High is the maximum. Array of high, I'm putting that value in the pivot. The last element is the pivot element. So what will be the next goal? The next goal is to put that pivot value in its correct position. My goal is to put that pivot value in its correct position. So pointer for greater element. So I will take a pointer for that, I low minus 1. Okay. Then I will traverse through all the elements. So I will check this pivot element with all the elements. I will compare each element with the pivot. Why I am comparing each element with the pivot? Because I want to put that element in its correct position. So I have to compare that pivot value with all the elements. So for that, I have taken for loop, J loop, for starting to the end, and every time it is comparing with the pivot value. If array of J that is less than equal to pivot, if it is less than equal to pivot or not. Okay, if the element is smaller than pivot is found, if the value of any element that is smaller than find I, then what will I do? Then I will swap it with the greater element pointed by I. Then I will swap the value. If the element is smaller than pivot is found, or then and I will increment I equal to I plus 1. And then I will next compare. After that, I will swapping element of A of I with element of J. Okay, then this is the pointer. I'm swapping these two values. If array of I and array of J, then I'm just swapping array of J and array of I. Now I have swapped these two values. If I have found any element which is less than equal to our pivot element, if the pivot is greater than if the element is smaller than pivot, if the element is smaller than pivot, then it should be in the left hand side. Okay, then it will swap the pivot element with greater element specified I. Okay, I have incremented I plus 1 an array of I, and I have swapped these two values. Okay, if element is greater than pivot, then it will be in the right side. Then I will return the position where the partition is done. After that, where my pivot element will be fixed, that will be the final position, because after swapping, after comparing each element with the pivot element, if the pivot value is greater than the key element, then I will put that element on the left hand side. If the element's value is greater than pivot element, that will be in the right side. According to this, I have find out the correct position of our pivot element, and according to that according to that position, I will partition the array into two halves not equal to half according to that pivot element. That will be returned at that position. Okay. Then the function of perform quick sort. I have taken an array, one element low and high. If first element is less than I, of course, this will be the condition. Then what is the goal? I will find out the pivot element such that element is smaller than pivot are on the left hand side, and the elements which are greater than the pivot, that will be on the right hand side. According to that element, according to the pivot value, that is pi, the position, according to I will partition the array. Now the partition algorithm will be, the partition function will be called, which is described here, the partition one. This is the partition. Okay, according to the value of our pivot position. Okay, recursive call on the left of the pivot. Again, this recursive call will be done on the left hand of side, pi minus 1, and same recursive call on the right of the pivot element, on the pivot element plus 1 position to the high. So both side, parallelly both side, the recursive call will be done in the both side, the elements which are left than the pivot and the elements which are greater than the pivot. Then I will find out the sorted array, that the data, suppose I have given this data, this is the unsorted data, size, length, all the, then I will find out, and the last, the sorted array in the ascending order. So this is one approach, one more approach of divide and conquer algorithm. Okay, if we talk about the complexity of our quicksort algorithm, okay, then the complexity depends upon our partition functions. Okay, so the maximum complexity of our quicksort algorithm, that will be our order of n square, which we have already discussed also. Okay, this is okay. If I take according to this, okay, if I always take first element as a pivot, then the complexity will be order of n square. In this case also the complexity will be n square. If I take random, then the average case is also order of n square. If I pick a medium every time, that the complexity of our quicksort, that will be our n log n. That will be the complexity analysis of this algorithm. Okay, that is the complexity analysis of this algorithm. Okay, and in the merge sort, every time I am dividing the problem into just equal to halves. Okay, so the complexity of merge sort algorithm, that will be always n into log n, because every time I am dividing the problem just equal to halves. So by dividing the problem is just equal to halves, the height of the tree will be log n, and in every pass it is taking n time, so the complexity will be n into log n. Okay, and in the knapsack problem, in the first one, in the knapsack problem, the complexity of our knapsack problem, that will be order of n log n, where n is the number of given items, and I am finding the ratio and sorting items. So if I am taking the best algorithm for sorting, that is n log n, and the by putting value, it will take constant time. So the complexity of this knapsack, fraction knapsack, that will be our n into log n. Because if I go to individually, by putting the value, it is take only constant time. It will take only constant times. Okay, and if I'm doing this, then it will take only constant time. If I'm sorting elements, it this one is to take your n time. These element these line of code, that will take to constant time. This is your n time, and this function will take n log n time, and remaining this will take n time. So overall complexity of this algorithm will be n into log n time. Okay, this is the analysis of our knapsack problem and merge sort and quick sort. Actually, this is not a design and analysis of algorithm part. It is a program explanation according to your requests. Okay, this is our knapsack and merge sort and quick sort explanation, and I will share this PDF sorry, this Word file in your group also. And your requirement is for lab manual. I will also share the lab manual in the group. Okay, is it clear?
Okay, sir.
You can also find out the lab manual from IGNU EGYAN course. Okay, in the IGNU EGYAN course, you can see your total in IGNU LMS. You can find out the content of design and analysis of algorithm web design lab. Can you access IGNU website, EGYAN course?
Yes,
Please
yes.
share the link, sir.
Okay, I will share. Okay, I will share the link in the group. Okay, and I will also share this document. And there is one suggestion for you. Kindly make this program. Okay, and read one more time all the programs and understand. Okay, if there is any problem, then we will also discuss in the next class also. Okay, class.
Okay, thank you.
Okay.
Sir, if you run the program, then
What?
how we will run the program?
Yeah,
We
you
don't know
run the program in your system. Okay. I will in the next class we will also discuss if there will be any problem in it. Okay.
Okay, sir.
Okay. Okay, class. Thank you so much.